Hello everyone and welcome to episode 2 of the Simple 3D Platformer. We left off last video with our character being able to move around quite simply here. And if we head down, you'll notice it has kind of an odd bumping motion. And also, the movement is not relative to the camera. Like I'm holding up right now and it's going off to the side. And in this video, we will be fixing both of those issues, as well as making it so that we can actually accomplish a goal in the game. So it's better if we can visualize this goal. So let's start off and actually create a goal that we can work towards. So let's go ahead and snap this there. And we're just going to create a small platform that we can walk on. Scale that out. Let's create another one. Up you go. Scale it in. Move it over here. So we're going to have to be able to jump in order to get to this. And perhaps we also have maybe a wall that we need to turn the camera to get around, or at least have the camera in a different orientation. And let's go ahead and scale this out. Move that down. And let's create the target that we're shooting for. So let's create some 3D text. And let's see here. Should have it right here. And for the text, we're going to have a star. Ah, yeah. Oop, not F. That was to zoom in. So right now we've got a white star. Let's go ahead and make it yellow. Because why not? And increase the font size, which just gives it a higher resolution. And then we can scale it down afterwards. Also note that 3D text actually appears through walls. And let's just add on a hinge joint to it and make it spin around. So check use motor and then maybe set its target velocity to 180 and then infinity force. Infinity. There we go. And now if we hit play, we should see this thing rotating here. Except for it's not around the right axis. We need to make sure that the axis is pointing up. Alright, and make sure that the axis is aligned in the right spot. Slide it over. And there we go, that should be good. There we go, now we've got a rotating star that we can see through the wall. But our goal will be to get our character to get to this star. And to do that, we'll have to be able to walk up the ramp and be able to jump up here. So let's go ahead and open up our simple character script. Hit reload if necessary. Alright. And we're going to need to rotate the input vector to match the rotation of the camera because that's where our view is from. So let me actually open up Paint Tool Sci here. Alright. And let me just draw out the way things look right now. So this is like looking from the top down. So we've got this is the x-axis and this is the z-axis. And we've got our character right here. And our camera is floating around right here. And it's got a view like this. And right now our motion is just being applied so that this goes like that. Our character moves in that direction even though our camera is over here. What we want to do is somehow get the rotation of the camera and turn this vector so that it matches the rotation of the camera. So the way we do that is by multiplying the rotation and the vector. And it's actually just as simple as that. However, we do first need a reference to the camera. And the way we do that is by creating a public transform. A transform in Unity is just a way of storing an object's position, rotation, and scale. And we can call it whatever we want. We'll call it camera transform. Again, its name is irrelevant as long as it makes sense. And if we go into Unity, after hitting save, and select our character, you'll see it now has a field that we can drag and drop a transform onto. And we can just drag and drop the main camera from the hierarchy right onto it, and now the script knows about it. So back here, now we can use camera transform inside update here, and we can do stuff with it. So our objective is to rotate my vector. So we want to set my vector equal to something. And this something is to be the rotated vector based on the rotation of the camera. And the way you get the rotation of something is by taking its transform, so we've got camera transform, and then hitting dot, and in the menu that opens up you can hit rotation, and then multiply it by my vector. And that's it. Just multiplying the camera rotation by the vector rotates the vector by the rotation. And if we hop back into Unity and hit play, where'd it go? It literally disappeared. So even though I didn't press anything, it just randomly shot off, and that indicates to me that there is something in the script that is acting independently of our input. And if we go back into the script, right here, where we set my vector to y equals 9001, that's what's doing it. So let's comment that out, and then go back into Unity, and hopefully it doesn't shoot off like a cannon again. Alright, hit and play. And now it's moving relative to the camera. We still have gravity in effect. But we still cannot jump, and we will take care of that now. As I described in the last video, we're using simple move, which means that it ignores the velocity on the y-axis, which means there's no way for us to directly make it jump, which means we have to use something other than simple move. The alternative to it is using move rather than simple move. So let's just remove simple from this and see what happens. Move simple, hit save, tab back into Unity, and hit play. And suddenly it moves really fast to and from the camera. So if we take a look at why this is, let's hop into the scripting reference, help, scripting reference. Now we'll open this up, and let's search character controller. And let's go down to move and see how it's different. A more complex move function that takes in absolute movement deltas. And you'll notice it says motion here rather than speed. So let's look at what that means. Let's hop back into Visual Studio, and instead of doing this right here, let's try doing it in Start and see what happens. Start, just rename it. You don't need to actually do this. I'm just going to set these things just for demonstration. And we're going to set like my vector to 5 and 5 and 5. And since it's in start, it will only be executed once. Now if I go into Unity and hit play, notice the character seems to disappear. But if we select the character right here and go into the scene view, notice they basically just teleported out here. And the reason for that is the movement that we gave it just sent it there in one jump. So we should only be moving it 5 and X, 5 and Y, and 5 and Z, but it sent it all the way over there. And that's because it is moving that amount rather than moving with speed. So even though we're just calling it once, it's sending it all the way out there. And if we do that in update, then it ends up happening every single frame, which is why it was moving so fast. Update. Alright. Set these back to 0. And make sure we're getting input again. Alright, so now it's back to what it was. Confirming, just hopping into Unity, make sure. And it is. The way that we deal with this is by changing it from the moving it that much per frame to moving it that much per second. And Unity has a really convenient way of doing this, and that is by using time.delta time. It sounds complicated, but really all it means is multiply something by it to change it from per frame to per second. So if we hop in here and multiply times time dot delta time, you'll see it pop up in IntelliSense, and then hit save and hit play. Now we've got the same movement as before, pretty much. It's moving awfully slow compared to what it used to be, but it's still moving. And it does slide along gliders. But you'll notice there's no gravity being applied. You might think we can just set like a negative value here. So let's say we'll set y to -1 and see what happens. Actually, let's multiply it by times... Hello? Alright. And it gets multiplied by time.delta time down here, so wouldn't that work? If we hop into Unity So -1 should move it down, and it does move it down, but you'll notice there's no acceleration, like it moves down at a constant rate. So we have to do something a bit different for gravity. So hopping back into the script, we will need to make it accelerate. And the way acceleration works in real life is you have an object that's moving at a speed, and then you add more speed to it continually. And that's acceleration. So the way we're going to do that is retrieve the current speed of it, and then add more speed to it again in the y-axis. And we're going to do it after we rotate the input vector, because we want it to always be heading straight down. Not down relative to the camera, just straight down. So we're going to go myVector dot z equals another something. Speaking of which, let's change this to rotate input to direction of camera. Or I guess it's by direction of camera, not to. Alright. So this something right here, we need to add accelerate new speed to old speed for acceleration. So how do we get the old speed? The character controller can actually help with that as well. So if we type out my controller and hit dot, you'll get another menu that pops up. It conveniently has something called velocity, and that is a vector 3, which is just like our myVector up here, which means that we can access its x, y, and z components separately. And what we want is the y direction, because that's up and down, and we want how fast it's moving in y. So we will retrieve that, and then down below, we need to set it to a temporary variable, so we'll create a float, which is, remember, is just a normal decimal number. Vertical velocity, the name is irrelevant just as long as it makes sense, equals myController.velocity.y. And then it's going to be myVector.y, not myVector.z that we set. And in order to get it properly, if we simply set vertical velocity to myVector.y, then nothing will happen. So if we hop into Unity, well, a little bit should happen. So you see now it's just moving back and forth, straight, oh, and then it shot into the air. And if we pause and look at the location, we see a very large number here. And the reason for this is because characterController.velocity gives us the speed in units per second, but we're telling the controller how far to move each frame. So what ends up happening is, say the character is moving at maybe 0.5 units per second in y, we're telling it to move 0.5 units in a single frame, and that corresponds to a huge increase in velocity that ends up being repeated over and over again each frame, which is why we got an insanely high number for the position of the character controller. So what we need to do is multiply this by time.delta time to make sure that we're telling it how far to move in the single frame that is corresponding to its speed per second. Hit and save. See what ends up happening if we tab into Unity. There we go. And this time it doesn't shoot up, it moves up at a constant velocity. And that's because we're not actually applying any gravity. We're moving it by the amount that its velocity previously was. So if we hop back into Visual Studio, let's create another public float, and we'll call it public float gravity strength. And we'll start it with a value of 5. And down here in myVector.y, in addition to the vertical velocity, we should also subtract the amount of gravity that we're applying. And this is because we want to apply the gravity every single frame, and as I described earlier, how acceleration works is you just add the velocity to its current velocity repeatedly, and that gives you acceleration. So then we subtract gravity strength, and then tab into Unity, hit play, and what do you know, we now have functioning gravity. We can go up the ramp and drop down immediately. And if we hop over to the capsule here, and we set the gravity to, say, 1, you can see it falls a lot slower than it did before. However, you might notice that even so, for a gravity strength of 1, it still seems to be dropping pretty fast. This capsule is 2 meters high, and normal gravity is 9.8 meters per second. Yet, even with a gravity strength of 1, it seems to be dropping like a rock. And the reason for that is we need to multiply our gravity by an additional time.delta time. Whether or not you have taken physics or calculus may determine whether you find this confusing or not, but we do need to do it. If you don't have any experience in physics or calculus, then you can actually just do trial and error, since there's a limited number of places where you can use time.delta time. If you find it too confusing, just maybe 5 minutes of experimenting, just adding in values. If it doesn't seem correct, will net you the right answer, usually. So if we hit play now, with a gravity strength of 5, it seems to be moving a lot slower. There's also an odd bounce that it has. But to test if this is the actual way it's being applied, like if this corresponds to actual physics, let's set it to the actual amount, so 9.8. If our keyboard is in the right mode, 9.8. Alright, now let's raise this up and duplicate it. This is just for demonstration purposes, you don't need to follow along. I'm going to go ahead and remove these components and add a rigid body, which is for physics interaction in Unity. And make sure use gravity is checked, and it's at the same height as the other capsule, so theoretically they should hit the ground at about the same time if the gravity strength being applied is correct. And if we hit play, you can see they basically do. Because we're doing this in an update function, it's going to be a bit different, but if we were to remove the time.delta time from there, again this is just for demonstration purposes, so if we were to go back to what it was before, and hop back over into Unity, and then hit play, you'd see it looks a lot different. The character controller basically teleports to the ground. So we can confirm that this is actually the correct way it's supposed to be. Alright, so now it's time to implement jumping. So first we need a jump speed, so public float jump speed. And let's go ahead and give it a value of 10, and again that just makes it so it's visible in the Unity editor here. So right over here we now have jump speed that we can adjust. And somewhere we need to increase the vertical velocity of this by the jump speed. So let's just try that right here. Let's just do jump speed plus my controller.velocity.y minus gravity, and then hit play and see what happens. You'll notice it disappears. It just shoots straight up if we look at the y value right here. And that's because we're not telling it to only jump when there is input. And the way we do that is by using input.getButton. Again, getButton down rather. Again, you could use the Unity scripting API, or rather the help online, by simply going to help, scripting reference, and then over here, searching for input, and then looking at what it has. And in this case, we want to either get button down, or get key down. Either one will work. Looking at the specifics of it, get button down accesses the input settings. So right here, you can see we already have an axis named jump, and it's mapped to the spacebar right here. So if we go into Unity, or rather Visual Studio, we have to figure out, alright, how do we get the jump button? And now we're introducing something new into the programming, and that's control statements. So things that will change the behavior of the program conditionally. So if something is true, then it will do one thing, otherwise it will do another thing. So let's go ahead and remove the jump speed from here, because we know that that doesn't quite work. And the way you do that in C# is with an if statement, usually. So you begin with if, and then you have parentheses. And inside the parentheses, you have something that is either true or false. It could be if a number is greater than another number, if two strings or words are equal to each other, if the object's position is above a certain height, anything you want. And then what happens after between braces is what gets executed if the condition that's in the parentheses is true. So let's say if input dot get button down And if you looked at the example on the Unity scripting reference, you would see that you would simply type in jump here, since we have a corresponding input in that in the Unity input settings. Then we want to somehow add jump speed to vertical velocity. But how do we do that? Like if we try to go vertical velocity, if you're following along, it won't pop up in IntelliSense. Even though we've got vertical velocity here, it's not popping up right here. And that's because this variable is being created afterwards. However, if we move this above the if statement, also you can move lines if you hold Alt and use the arrow keys up and down. And then we try typing out vertical velocity again. Vertical velocity, you see it pops up in IntelliSense. So we could do the normal equals vertical velocity plus jump speed. Or we can do a shorter version of it. So you'll notice we've been doing this a lot. We've been doing a value equals its own value plus something else. C# actually has a shorthand way of doing that, and that's plus equals. So vertical velocity plus equals jump speed is the same as vertical velocity equals vertical velocity plus jump speed. It's the exact same speed, or exact same thing, just a short way of writing it. Now let's hit save. Up back into Unity, hit play. It should drop down like before. Alright. And if we hit space, you see it hops up in the air. And now we can run over here. Hop up on top of the ledge if our camera is better. And if we drag the scene view down and get a separate view here, you can use this to guide it. And we're at the star. Yay! However, you'll notice we can jump multiple times. And that will be taken care of in the next video. Before then, we need to make it so the player can actually collect the star, because right now we just kind of pass through it. And in order to do that, let's go ahead and create another script. And this one we're going to put on the star. So let's go right click, create C# script. And we'll call this player collect. And this will be attached to the star object that we need to put a collider on. So let's add a sphere collider to it. And make sure it's marked as a trigger, because we want it to trigger when the player enters it. So it's a bit off center, not too worried about that. Let's slide it a bit to make it more centered. So we want to slide it in X. Make sure it's centered around the star. There we go, perfect. And let's also move the whole thing up a bit. So we want it so that when the player gets over here and comes and jumps, it sends a message to the script that in some way indicates that the player has actually reached the star. So let's open up the script that we just created, player collect, and hit reload if necessary. Hop down here. And the way that Unity handles collisions, there's actually a lot of different ways you can do it. So before we had void start, and then we put stuff in here. There's one that Unity uses every time a collision happens, and that is void on trigger enter. But it only happens if one of the objects that collided is marked as a trigger, and at least one of the objects has a rigid body attached. However, rather than just empty parentheses right here, it also has an argument that's passed in, which is just another parameter, and that's a collider. And we can give it whatever name we want again, as long as the first part is collider, and that's just to match with what Unity defines the function to be. So if we hop into the scripting reference again and go into on trigger enter, let's see, just as it has here, void on trigger enter collider other. Again, the name is irrelevant as long as it's collider, and the method name is on trigger enter. It's worth noting that this is called only when the colliders enter each other, not if they remain in contact or exit each other. So in here we want to do something that lets the player collect the object, or in some way indicate that they passed into the object. And for now, let's just do print. We'll have this object's name plus has been collected, and we will print that into the console. And that's actually all that we need right there. So let's hop back into Unity. Also make sure we change this name to star so that the object is correctly named. And we already have the component attached to it. And let's go ahead and rotate the camera so we got a bit of a better view. So let's select the main camera, game object, align with view, hit play. Wait, did we actually add the script to the star? I believe we did. No, we didn't. Alright, so we need to add player collect. Alright, there we go. So now it has the player collect component on it. There's no parameters that we need to set. Now we hit play. And go ahead and move the player up the ramp. Hop up. And you notice in the console down here, we now have star has been collected. And that will be it for this video. However, in the next video, we will take care of a few issues that may not be readily apparent. The first of which is, let's say I rotate the game camera to an angle like this, and say game object, no, we need the camera, game object align with view, and we hit play. You notice moving up and down, the object goes really slowly. And that's because rather than moving relative to the ground, it's actually moving it towards and away from the camera directly. And that's not as straightforward to solve as you might think, but it's still relatively simple. But additionally, we will also take care of making it so the player can't jump repeatedly, as well as making it so the player can wall jump, which is going to be really interesting. So until then, thanks for watching.